Whenever you go exploring, you never bring everything with you. You always kind of live off the land. Even when we go on road trips, right? We buy gas going, as we travel, and we buy food as we travel. Well, when we go exploring, we need to do that same thing. We need to live off the land. We need to live on the lunar surface, and then eventually we need to go onto Mars and be able to live off of that surface.
The main things that we have available on the Moon and Mars, primarily we have oxygen. The lunar regolith is about 45% oxygen roughly. There's a lot of ways to get that oxygen out. This is one of the processes that we're testing today is a well-proven method for extracting oxygen from lunar soil or regolith.
As we go forward, we need to be in a lunar-like environment. And a big chamber like this allows us to get into that lunar-like environment. This test is extracting oxygen from lunar simulant. And what that is going to enable us to do is live off the land on the lunar surface.
So this is our 15-foot dirty thermal vacuum chamber. We use it to simulate the surface of the moon because on the surface of the moon there is no air. That means that convective heat transfer does not occur, and any hardware that you build, you need to make sure that it can withstand that harsh environment. So here in the chamber right now, you see our industry partner, Sierra Space's built reactor. We use this reactor to melt lunar regolith simulant.
So we have a reactor that was developed by a commercial company, and we are integrating our gas analysis system with that reactor. And so we have a laser that is going to deliver energy to the regolith, melt the regolith, and we're going to extract the oxygen that way. And then we analyze the gas products with an instrument that is actually flight forward. And so we have a mass spectrometer, and that mass spec is going to be delivered to the moon on earlier CLIPS missions. And so we're using that technology, that partnering with industry, to enable us to analyze the gases and have a path forward to flight.
So this will increase what we call the technology readiness level because we're performing the test in a relevant environment, the vacuum being the relevant environment. So what the vacuum chamber does is make sure that our thermal management approach is working well.
Our gas analysis system is designed to measure the efficiency of oxygen production. So how much oxygen are we really making with this process? So it's really exciting to be part of that ground floor effort to get that technology ready to support our next big exploration push.
This is really the first step in a series of what I think would ideally be a campaign to where we get to the point where we're extracting useful quantities of oxygen on the lunar surface. So this first step lets us know that we can perform the process at least at a small scale. What we're doing today is something that's never been done before, so that's always exciting.